examples to tell you what to do. Okay, so I'm going to write down the things that you actually need to know. As I'm writing it down, right, you yourself actually try to think about it. Do I actually know what Mr. is talking about? Okay, so I'm writing it down now, and later, better actually put it on a piece of paper, and later, when you're going through certain questions, right, tell yourself, okay, for these things, right, this question actually tells me what to do. Okay, the very first thing that you need to know, illustrate, collinearity, correct? Hopefully you know what I'm talking about. Later, I will talk more about it. Ratio theorem, okay, right? Ratio theorem. Then, before we move on to lines and planes, right, we talk about two products, correct? One of them is dot product. Agree? Basic definition, if you dot two vectors together, basically it means that you times the length and then you times the cosine theta, where theta is the angle between the two vectors. Alright? Basic. Then the thing is, for this dot product, what are the uses? The uses is, you can use them to find projection length, projection vector. And this is the part whereby a lot of you have probably right. What do you mean by projection length? What do you mean by projection vector? Later when I actually go through a question, when I actually reach this part, right, I will actually do some training with you, okay, to actually strengthen the idea of projection, okay? Then it also allows you to find angles. Agree? Whenever questions got angles, what? Do you remember angle between line and line, line and plane, plane and plane? Actually, you use a formula that is actually with cosine theta. Alright, okay? And there's the last one, but this one, right, later I will tell you there's actually two ways to do it. But a lot of confusion can arise. It actually allows you to find the perpendicular distance from a point to a line. Remember this? Okay, later, don't worry, later I will actually go through the training review. Cannot? Okay, then you have another product called what? Cross product, right? Now cross product, basic definition is this. If I cross, definition is I will get a vector. The thing I know about this vector is as follows. I know that the length of the vector is length of A, length of B times sine theta. Theta again is the angle between A and B. But because when I cross two vectors, you will get a vector, right? Okay, by definition, you actually get a vector that is perpendicular to both. And hence, you actually have an n hat there. Okay, n hat. Okay, why need a hat? Reason being that I want the length of this vector to be precisely mod A mod B sine theta. The n hat is just telling me, oh, the direction is perpendicular to the two vectors. Understand? Okay. Then what is the what is the application of this? Well, the very basic application is it allows you to find a vector perpendicular to two vectors. Agree? Alright. Every time you need a vector that's perpendicular to both, you do a crossing. Agree or not? Still can recall, Still following me, If I'm too fast, please stop me because this is a revision lecture. Okay? Then it allows you to find area of triangle, correct? Remember? And also allow you to find area of parallelogram. And there's actually the last one. It also allows you to find perpendicular distance from a point to a line. Correct? There's two ways. But this part, later I'll go through with you. Actually, I prefer my students to go through the long way. Okay, what's the long way? The dot product. The short way is actually the cross product. But the cross product has a certain misconception that you all will get trapped inside. So later I'll actually tell you what is it. Okay? Okay, with this, what's next? Then I will go into lines already. So, lines. You need to know that the equation is like that. Agree? By now, I think you also know what's A, what's B. Alright? I just revise with you. R is a point, any point on the line. I feel so pumped up. This is a point on the line. And this is a vector parallel to the line. Correct? But then, depend on situation, you have different ways of finding the equation of line. Correct? Think about this. How to find what is the situation that can be given to you to find the equation of line? 2 points. The line passes 2 points. Agree? Does it allow me to find the point of the line, the direction vector parallel to the line? Okay, think about it. I give you a point and a vector parallel to the line. Also possible, right? Okay, so far so good. Can. Then after that, regarding line, what are the things you need to know? Okay, what are the things you need to know? Okay, you need to know how to convert the Cartesian equation to vector equation. You know what is vector equation, right? Vector equation in this form, correct? Cartesian equation, roughly still remember? Okay, you need to know how to convert from one to the other. Later, if you still cannot remember, I will go through it. Okay. Then, the thing that you need to know is as follows. There is 1, 2, 3, 4, 5 points you need to know. Okay, you need to know intersection between two lines. Okay, how to do it? Okay, you need to know angle between lines. Okay, how to get it? Everything you have to start to have some basic formula. If you do not have, means that your vectors is not there yet. Okay. You also need to know foot of perpendicular of a point to the line. Do you know what I'm talking about? Okay, a foot perpendicular from a point to a line. How to find it? Okay, you must have a way first. There's a few ways. I will show you the few ways, but you need to have one way to yourself first. Then later learn all the ways. Okay. Point 4. Shortest distance of a point to a line. How to find it? Okay, think about it. And then the last one will be how to find reflection of point about line. Can be extended to line about line. You know what I mean by line about line, right? That means I give you a line. Okay, I give you another line. One of the lines is a mirror. You reflect the other line over. How to find it? This one is a more advanced question. Later, I think I have a question inside the question I'm going to go through with you, then I'll go through with you again. Okay? But they are consistent idea across. Can? So roughly, So all this, think about it. What are the things you already know? Okay? What are the things you haven't known? So by the end of today, hopefully, all the things you know. Can? So after this, we'll talk about planes. Then for planes, right, there's a vector equation. The vector equation is R equals to A plus lambda. I don't know what your lecturer uses, but I think it's lambda D1 plus beta D2. Correct? A is what? A point on the plane. Right? D1, D2 is a vector that is parallel to the plane. Correct? Guys, you have to revise out. But there's another form, right? R dot n equals to a number. Correct? What is the R? A vector perpendicular to the plane. Agreed? Okay. So think about it. How to actually get the equation of the equation? How to get the equation of a plane? I give you a point. I give you two vectors parallel to the plane. Then get it ready. Agreed? I give you 3 points. Can you give me the equation? Think about it. 3 points. Cannot. Possible? I give you a vector perpendicular to a plane plus 1 point. Also possible, right? I give you a line on the plane plus an extra point. Can you give me the equation? Think about it. Yeah, how? All these things you need to know how. Because without the equation, I cannot do anything. Okay? Later, we'll go through this. Okay? Okay, then after that, you will actually need to know the following already. After planes introduced already, there's more things you need to know. Intersection, right? You need to know how to find between line and plane. Right? Remember? Think about it. Between two planes, how to find? Between 3 planes, how to find? Okay? Then you need to know about questions that talk about distance. Do you know how to find the distance of a point to a plane? Think about it. Okay. Line to a plane. What is the situation? Plane to a plane. Alright, you've seen this before, right? So how to find each of them? Okay. Later, okay, if anything later at the end of I go through all the 6 questions, things are missing, I will just fill them in with simple examples. Okay. Okay. Angles. Is a question involving angles. What do you need to know? Angle. Just now I talked about angle between lines, right? Correct? Guys, angle between lines, right? So here is angle between line and plane. Angle between two planes. Agree? Okay, how to find? Okay, next, there's question talking about foot or perpendicular. Just now I talked about foot perpendicular from point to line already, right? Correct? So you also need to know foot or perpendicular of a point to a plane, how to find it. There are a few methods. I'm going to go through all the methods with you. You select one that you prefer. Okay? Then actually, okay, I'll wait to see what else. Okay, so roughly like that. Then of course there's questions like reflection type of questions, whereby you can talk about a point reflected about a plane. Okay, this one appeared in A levels before. Line reflected about plane. This one also appeared in A level before. Okay. One more, I think haven't appeared in A level yet, but some college is actually given this type of question to their students. Plane reflected about plane. Okay. So how to find all of them? Actually, all these reflection type of questions have a basic idea to everything. Okay, once you know it, everything can be done. Can? So I will now start the questions proper now. Question 1 first. Okay. Okay, question 1, please read. I think for some of you here, you already read this already, correct? And I think these questions, why I include this is because I want to talk about ratio theorem. And I think ratio theorem, a lot of you, right, actually is very familiar about it. But there is one particular issue with this question. Okay, please highlight it out. Okay, please highlight this up. Okay, there's a word there called externally. So what do you actually mean by externally? Okay, so the thing is this, if you actually have this phrase, which is actually not very common, but I will actually give it to you because 20 years ago A level actually appeared this, come up with this. I don't know whether or not they're going to test you on this again. So what do you actually mean by externally? If they say that S divides the line segment AB externally, it means that I only have two situations that can happen. Agree? You know I'm writing, right? That means the line segment AB. S is either outside to the left or outside to the right, depending on your orientation. Correct? Okay? But the thing is this, you need to know which situation because it cannot be both situations happening. So how do I know which situation? Okay, the ratio will tell me, but how? So how do I actually see this ratio? When I say that S divide AB, do you agree that I'm saying that 3:2 is the ratio of AS to BS? No direction involved, it's just a length. Agree? If I say that S divide AB, without the word externally first, and I say that S divide AB in the ratio 3:2, do you agree that I'm telling you mathematically AS to BS 3:2? If that's the situation, which situation should fit into this situation? First one, why? Why it needs to be the first one? Because who is longer? AS, right? And the only situation that AS is longer than BS is actually the first situation. Make sense? Okay, so that's why to start off to solve these questions, okay, the way to do it is you have to draw this A, B, S, A, B, S, correct? I say that's the situation, right? Okay, ABS. Then how do actually you find the ratio? Because to actually do ratio theorem, do you agree that this length and this length is super important to me? Agree? But then how to do it? Basically just by using numbers. Because I tell you that AS 3, BS 2, right? That's the question. That is how the question is being phrased, right? Agree? So I think you should know what this length is. Why? Agree? Then one thing, I think a lot of you when you actually draw the ratio theorem picture, right, you draw it like this. Okay? But I hope in your mind, your picture should look something like this. That means ratio theorem always allows you to find the vector with respect to the origin. Actually can be any point, but basically only to the origin because a lot of questions is about the origin. Is it okay so far? So from here, ratio theorem usually you just memorize. How to do it? Let's start it off. OB, which is the center vector, always start from center vector, equals to, this one is 1, this one is 2. 1 times the opposite vector. You always go to the opposite. OS plus 2 times OA divided by total of the number 3. Okay? By the way, this today lecture is going to be a bit longer. So if anyone here feel very tired, just have some food. Okay? Please finish the food. Yeah, it's from last week. Don't worry, the expiry date is still not up yet. Okay? Okay, so after you've done this, right, what does the question say? The question actually want show a certain relationship between A, B, C lah. So what do I actually have now? Well, based on the question, okay, tell me based on the question, what can I actually write down? This one is B, right? By the way, notation wise, remember if you have a vector, have a tilde below. Okay? Equals to, well, OS, I don't know anything. A got information divided by 3. So if I actually simplify, I know that OS is 3B minus 2A. Agree with me so far? Okay, yeah. Next thing is this. The point C with position vector C is such that O is the midpoint. O is the midpoint of CS. Alright, this is how I draw. Which means that OS is actually equals to, anyone? Yeah, equals to OS here. OC, okay, OC, missing anything? Yeah, a negative sign, right? Because the direction is opposite. Agree? From here, if I put in the thing, this is minus C. I also know OS being this. Which means that if I look at what the question wants, I just shift everything to the right hand side. And I think I will have my M and N already, right? Correct. Didn't give up, but this will be the answer. Done. Agree? But main thing about this question is, what is ratio theorem? Extra detail that you need to know. What do you mean by divide externally? How to find it? Okay? So ratio theorem done. Agree? Ratio theorem done. Okay. Okay, next up. Ready for next? Think? Ready? So what's good? Anything you don't understand, please stop me and clarify me. Okay? Now for B, line have an equation like this, the plane have this, show that the position vector B of the intersection between L and this is this. Okay, so how we do this? First thing first is, okay, listen up, this is just some historical fact. When you deal with planes, the best form is actually scalar product form. You know scalar product form? The one that tells you what? The norm. Okay? But because you have GC, this form here is also quite manageable. Later I will show you to find this intersection, I can use this form directly. Okay? But for the line equation, Cartesian is the worst. You can basically don't use it. Which means that every time a Cartesian equation is given to you, which means that the Z and the X and the Y is given to you, change it to vector equation. Okay, only the vector equation is useful for us. Understand this? But then you need to know how to change. Okay, so how to change? Okay, the way to change it is, if I read this, do you agree that they are telling you Z equals to 1 minus 2x? But separately, they tell you that Y is always equals to 5. Which means that to actually get the thing, I will just say lambda equals to Z, lambda equals to 1 minus 2x. You know the lambda in your lines, alright? And then the Y is just 5. Understand? The Y is just 5. Which means that I know that my equation is going to look something like this already. 5 in the middle plus lambda, this one is 0. Make sense? Because I'm telling you the y is always 5. Which means that the lambda is not going to affect the value. Make sense? Huh? The only thing now I need to know is what is the x coordinate like, what is the z coordinate like. So if you actually look at this, is okay, lambda equals to z. Correct? Lambda equals to z. So what you actually need to do is you need to make x, y, z the subject. Y is already the subject. Okay? So to make x a subject, you just shift around, divide by 2, which means that my equation, which is R, which is x, y, z, will just be 1 minus lambda over 2, 5 lambda. Split 1, 5, 0 plus lambda minus half 0, 1. Agree, right? Can see all? Yep. What? Oh, sorry. Extra. That's why. Why? Here I haven't filled in yet. Because I already know that y is always 5. The whole thing I haven't filled in yet. But if you don't follow this, you just follow what I have lah. In terms of x, in terms of z, y is 5 so can you see that I can write this down? This is how you reverse the process. Remember how you actually get from vector equation to Cartesian? You let everybody to be equal to, you let x equals to what? Then you make lambda the subject. Do you remember? Then you equate. I'm just reversing the process. Okay, seems that there's a lot of issues. Is it okay? Is it half? 50. Okay, we are 50. Oh yeah, it's half. Sorry, miss out. Thank you. Correct now? Is it correct? Correct. You have to focus. Pay attention because I don't have a solution. Is it okay? Okay. Okay. So what? After I get this all, okay. Let me write here. So it's R equals to minus half 5 0 plus lambda. Is it minus half 0 1? Is it correct? Sorry? Half. Yeah, let me double check. Minus half, right? Oh, half. Thank you. Like that, right? Can. So what's good? Please double check. So what's good? Okay, everyone okay. Here comes the next part. I think your tutor have said that you can do some change to the equation, right? Correct? What change can you do to it? You can do to it only on the direction vector. The point cannot touch. Can. Okay? So I want to change it because I hate to deal with fraction. So I do it like this. Is it okay? Okay? Make it nicer lah. But if you want to keep it as minus half 0 1, possible. Go ahead. So far so good? Yeah. So good. I have the equation online to work with already. So how to continue? By the way, all of you actually take out the GC as well. Well, to actually show that the point of intersection between this and this is minus 24, 5 plus 49. If I don't want to do anything, I just do this. The equation of the line is equals to the equation of the plane. I don't do anything. I just throw everything in. Correct? Agree on? Agree on? Is it okay? Can. By the way, I want to also do some revision before I go on. This equation of the line, if you look at this, right? I have a few questions now. Give me a point on this plane. The most direct one, I think you can just say this. Minus 1, 0, 1, right? Give me another one. Now this is why I need you to treat. Give me another one, anyone. Do you agree that it's 0, 0, 0? But how do I know that 0, 0, 0 is on this plane? How do I know it so fast? What do I actually do? I actually let my alpha to be 0 and my beta to be 1. Yeah. That means what I'm trying to say is that to actually find any point that you like on this plane, you just basically sum alpha, beta to be any value. Any is any value. Understand this? This is what this equation is telling you. Is it okay? So if that's the case, how do I actually find the intersection? You just basically say that, oh, the point on the line is equal to the point of the plane. Common point, agree? Then you look at what you have. Do you agree you have 3 unknowns? But how many equations you also have? 3 equations. So I think you know what I'm going to do already. I'm just going to use the GC to solve. So for those who haven't done this question yet, help me to actually solve this by GC. I will set up the equation for you. Actually, don't even need to solve already. I actually done already. By the way, wait, I shift everything. 2 lambda minus 1 minus 3 alpha plus beta equals to 0. But do you realize one thing? Okay, so I will do it something like this. This means that my equation will be lambda plus 2 alpha plus beta equals to 3 over 2. Alpha is 5. 2 alpha minus 3, 2 lambda minus 3 alpha plus beta equals to 1. Solve. Answer? Yeah, I need an answer. By the way, I only need one answer. Do you know what answer will I be focusing on? Anyone? Make a guess. Lambda, alpha or beta? Lambda. Why? Because once I have the lambda, I just sub it into the line, right? In order to actually use alpha value, I need the beta as well. Make sense? Because I need to sub both values into the equation of the plane. Understand this? Here, okay? So, one thing, what is the value of lambda? Come on, help me out. So, lambda equals what? It's going to be very ugly. Huh? No value. 127? So big. Sorry? Do you all get it correct? Let me double check. Why did you get this correct? 59 over 2. 49 over 2. Okay, sounds a bit right. 49 over 2. Alpha is 5. Beta is negative 33. Over 2. Right. Okay, which means that my point of intersection is basically equals to half minus 49 over 2. Correct, yeah. 5. 2 times 49 over 2. Yeah, correct, yeah. Okay. Giving you the answer as, which is what the question actually wants you to find out. Minus 24, 5, and 49. One more thing, your answer, please don't leave it as IJK. Always give it column vectors. The reason why we use IJK is because for we settle as for questions, we want to say space. Okay? IJK, I mean that don't write your answer in IJK form. Okay, column vector form is the same as IJK form, correct? Okay. Okay, now read. I'm given OA because I'm given the coordinates as minus 7, 10, 3. This is a positional vector. Then the question asks me to find the length of projection of AB onto pi 1. Agree? AB onto pi 1. So how does the picture look like? I need you all to always think about the picture. This is the plane. Correct? Okay. Where is A and B? Tell me. You read the question. You have to read the question. What do you know? What do you know? You have to read the question. What do you know? Read. Guys, you have to read, or else you do not know what I'm talking about. Your mind has to be working now. If you have no sugar rushing to your brain, get some food to eat. Tell me, what is the picture look like? Come on. Do you agree that B is here? Because I tell you what, B is the intersection between line and plane one. B is on the plane. Make sense? A, I don't know, so somewhere. Fine. Okay? And what does the question actually want is, they want you to have the length of projection of AB onto the plane. Do you know what they are asking you for? They are asking you for this one. Agree or not? Project down. Wow. Make sense? Agree or not? Here comes the part. For planes, the only thing I can play with is the normal. Please do not tell me that, oh, I know a particular vector on the plane. Okay, do you agree that some of the vectors that's on this plane is 2, 1, 3, another one is 1, 0, minus 1? Do you know where this comes from? Read the question again. Do you know where this comes from? Right, it comes from the equation. Make sense? So you will tell me, oh, I have a vector on the plane. I just project it onto the vector. Is this correct? No, right? You know what I'm saying? Okay, what I'm saying is this. You see how you have a vector on this plane, right? Correct. Then the thing is, based on the equation, this is vector 2, 1, 3. This is vector 1, 0, minus 1. Agree or not? Can be anywhere. I just anyhow fix them. Make sense? Then the thing is, AB is somewhere here. But the thing is, you actually want the projection length of AB onto the plane, right? Alright? But do you realize that you cannot just use any one of them? You look at this picture. Standard a bit. If you project it directly down, you actually need a very special particular vector that is so-called directly below the vector. Make sense? But the thing is this, can I find that? No, it's impossible to find that. Agree or not? However, think about this. The thing is, if let's say now, I have the normal. Do you agree that no matter where my vector is, I project onto the normal, it will always give me a fixed value? Okay? But of course, you are going to tell me this. If I project onto the normal, I'm not getting the thing that I want directly. Correct? However, think about it. If I project onto the normal, do you agree that this is the length I get? Then once I get this length, I think this length will come out, right? Agree? How? Pythagoras theorem. Make sense? Make sense? Make sense? Okay. So this is how I can get it. And since now I'm actually at the topic of projection, it's a good time for you all to do this visual training. You can see all the 1, 2, 3, 4, 5, 6 vectors. Can see all? Okay? This color is called what? Maroon? No. Pink. Just call it pink. Okay. My question now is this. I want you to give me, listen very carefully. The projection vector of red onto orange. How does it look like? Okay, imagine your mind now. Imagine your mind now. I'm just going to write the answer. Can you see the gray? You can see, right? I'm just going to draw it out for you. I repeat, the projection vector of red onto orange. It should look like this. Make sense? Yeah. The orange onto the red. I give you the answer again. You now see why I want to go through this visual exercise with you, because the problem with your lecture note is every time the lecture note talk about projection vector, right? Always very nice one. The thing that you're projecting on, right, is always like horizontal. But in situations when you're actually drawing on your diagram, it may not be, you see. And that's the reason why I need this training. Do you know how I actually get the both of them? What you actually need to do is, when you have red project onto orange, do you agree that the orange is like the mirror or the screen catching the shadow? So you actually need to have a mirror that is parallel to the orange color. Then what do? The red will fall onto the thing. You know what I mean by fall, right? It means that you actually have to form a right angle triangle like this. And then this will be the shadow. And then it will follow the direction of the thing that you are projecting. Make sense? Okay, this is training, yeah. Then for the orange onto the red, can you see that I don't really care about the thing that is onto? The screen can be very small, fine, but I just stretch it. Then I just project onto it by a right angle triangle. Can you see the right angle triangle? Like this, right angle triangle. And then the direction follow the thing that you're projecting. Understand this? Okay, this is thing you need to understand. So let's train more. Orange onto pink. So in your mind, what you will actually imagine? You will imagine something like this, right? Mirror. Agree? This mirror is parallel to pink. Then what do? You draw a right angle triangle, correct? And this will be the projection vector. Make sense? Can you see now? Okay. Orange onto blue. About parallel. Correct? Like this. Okay? Orange onto green. Can happen. Why? Perpendicular, no shadow. Make sense? I can't do anything. Sorry? I can't, don't have. No length. I don't even talk about direction. Sorry? No. That means orange onto the green. Can you even have any vector? How to project? Orange on the blue. I don't know. It follows the one that you're projecting, not the one that you are on it. Yeah. Oh, do you know what I mean by follow or not? Same orientation. That means they're pointing in the same orientation. I can't point up. Because that would be the wrong orientation. Because orange is towards me. Correct? Towards me. So the orientation also has to be towards me. Make sense? Okay, let's do more. Black onto red. Agree? Black onto red. Can? Okay. Green onto pink. Correct? You have to get this. Then after that, the picture of projection will look more familiar to you. Is it okay now? Okay, last one. Last one before I go to the question again. This one will be tricky. Red on pink. Okay, it's very short. Is my direction correct? Good. Now can see so can see the projection now. Can see Is it okay? Can And if you can see the projection, I think it's also a good time to actually go through the formula. Can? Okay. You remember this formula, A dot B? Hat. It's actually for you to find projection, right? Correct? So which vector do you have it? Okay, let's go through again. So if you have blue onto green, agree that the projection vector looks something like this? Agree? Then which vector do you have it? Yes, green. The one that acts as the mirror, the screen. Agree. A, which is the one that you're projecting, keep it as the line. Understand? Then one thing is this. First, one thing this formula gives you projection length. Agree? But projection vector formula a bit different. What's the difference? Instead of a modulus, it's actually a bracket. Remember? And you always make mistake here. But why? Because look at this example here. Blue onto green. When you have blue onto green, when you do A dot B hat, do you agree? The answer that you get is going to be negative. Because why? Because the direction of blue is like that. The direction of green is like that. Do you agree that the angle between them is opposite? And hence the dot product is going to be negative. Understand? Okay? But because you're finding length only, you have to kill off the negative. Still follow up? But when you're finding projection vector, you have to keep the negative sign. Because why? You have to tell people that the projection vector of blue onto green is the opposite from green. Make sense, right? You look at what you have drawn. It's opposite, right? And hence the negative sign. Understand now? Okay. And then do you agree that projection vector you have to multiply by the b hat? Why? Because the projection vector is in the direction of the screen or the mirror. Make sense? Yeah. So take note of the difference. Understand now? Anything you want to clarify about projection, please tell me now. Is it okay? So how I always remember A dot B hat. What is hat? Hat the screen. Just hat the screen. A project onto B, hat B. B project onto A, hat A. That's it. Understand? Yeah. And the difference between the mod and the bracket. Okay, pause for a while. Any questions? Please think about it. I give you about 3 minutes. Clarify with me now. Agree. You see, what is the difference between a projection and the projection vector? When I talk about projection, do you agree that this mod A dot B hat only give me the length? That means this answer only give me this, like that. This is the answer, length. Agree? But does it give me direction? No. Correct? It doesn't give me direction. So how to actually get a direction or how to get a vector? Okay, let's go through this. This is something that can help you. Okay, do it here. Tell me something. Now I have in my mind a vector of length 8. Okay, so far so good? This vector in my mind is pointing in the same direction as 1, 2, 1. Okay? What is the vector in my mind? Is the vector 8 bracket 1, 2, 1 question mark? You all know, right? Because if I do it like this, yes, my vector is going to be in the same direction 1, 2, 1. But do you realize something? I have changed the length. Because why? Because I multiply 1 to 1. So how do I actually overcome this problem? Instead of multiplying 1 to 1, I multiply by 1 to 1 over square root 6, which is what? The unit vector. So do you realize what's the purpose of unit vector? It gives you the direction, but can keep the length the same. Make sense? So therefore, now if you actually want the projection vector, this projection vector, do you agree that I know the length already? A dot B hat. But how to give it the direction? Times the B hat. And then the negative from the A dot B hat will tell me whether it's in the opposite direction or in the same direction. Another 3 minutes. It is time to carry out. Cannot, because if you see if you do A dot B hat mod, do you agree it's positive? When you multiply the B hat like that, do you agree that this vector is going to be like this? In the direction of B hat, mod is positive. So agree that it's in the direction of green. Is that what you want as a projection vector? No. So can you see that the dot product gives you the correct direction? Correct. Because if you think about it, if I have a vector project onto another vector, do you agree that this projection is already in the direction of the screen or the mirror? It is no longer following the original vector. Yeah. And the dot product will tell you. Because if it's in the incorrect orientation, like blue and green, can you see that the angle will automatically become obtuse? And the dot product will automatically become negative. Now can you see the difference now? Why sometimes mod, sometimes bracket? So to actually help you, let's say in exam you're very afraid of making this kind of mistake, my advice, A dot B hat, always do it at A dot B hat. If the answer comes as negative and the question asks you for projection length, you just need to write down one more sentence. You just write down that the length is 10 whatever. Remove the negative sign. That's it. Understand? Because if you keep on remembering it's more, when I ask you for projection vector, you confirm make the calculation. Okay, so far? Okay, so far so good. So now how to see the projection length already. Projection vector, can? Okay, before I move on. Okay, this is the part. Listen. This one important. This is A, this is B lah. Can? Okay. I want this length here. How to find it? Class, give it to me. Formula? A dot B hat. Agree. A dot B hat. But my question is, so what does A cross B hat give you? Question mark. But why solar distance? Because here I don't have any point. Correct? I don't have any point. It actually give you which distance, do you know? It give you this one. So-called the distance that forms the right angle triangle. Understand? Okay, let's do more. Okay. Can if this is the case, I'm going to move back my picture already. Here. Listen up. Orange cross pink hat modulus. Which length will you get? Very difficult, right? So the way I always think about it is like this. I don't think of A cross B hat mod. Okay, I have to emphasize the mod because later I will tell you where the core mistake is. Okay? I don't think of A cross B hat first. I think of A dot B hat first. A dot B hat give me what length? Oh, okay. Orange dot pink hat give you what length? Here, right? Okay. So, orange cross pink hat mod give you. Understand? So always see the projection first, then the cross give you the opposite. Understand now? But I have a question now. Is this vector A cross B hat? I'm talking about vector. That means you know length and vector is different, right? So if I say that I want this vector, is this vector A cross B hat? No, because why? A cross B hat is actually where? By definition, perpendicular to both orange and pink, which means that the vector is actually coming out from my laptop. It's not on my laptop. Okay, question 1, like this, right? So agree that if I need to find the length of projection, there's one thing I need to go and find first. What is the important thing I need to go and find? Plus. As I said, for planes, right, there's only one thing I super want to go for it, normal. So how to get the normal? What do you do? Guys, come on, focus on the question. Cross the two vectors on the plane, right? Okay? And I hope the cross product, we can do it so that there's no mistake. Am I correct? Yes, I'm correct. Okay. Why you cross hat? Okay, don't anyhow hat. You hat only when you want to find length. You are not finding length, don't go and anyhow hat, because the hat got those weird square root cert values. You don't want to do that. Okay, understand? Yeah. But can I actually do 1, 0, minus 1 cross 2, 1, 3? Can, go ahead. I don't really care about the direction of the normal. I just need the normal. Can? Okay. So normal come out. So my question now is how to find, first thing, the blue. Okay, based on the thing that I said just now, how to find the blue color immediately with one step. The blue color, do I need a blue color? Oh no, I don't want the blue color. I want the orange color, right? The projection length. How to find this projection length in one step? AB cross, right? You use a cross, right? Agree? Because if you dot, you actually get one length. You get the blue color one. Correct? Correct? See the thing? So if you cross, you actually get the opposite. Make sense? Or I think the correct term is the complement length. But whatever, you know what I'm trying to talk about. Okay? So AB cross 1. Minus 1, 5, minus 1 over square root 27. Correct? And then, is this the length? No, right? You have to mod it, right? And do you know what is the meaning of mod, right? That means after you cross this vector, you got a vector, right? You have to find the length of the vector. Square, add up, take square root. Agree. So do it now and see whether you get the answer. Okay? Then for those who say that I cannot see, but I can see the projection, go ahead. So how to do the projection? You project and then you find the blue color length, right? Okay. After you find the blue color length, how to find the orange color length? You use Pythagoras theorem. But I have a question. To do Pythagoras theorem, I need the length of the hypotenuse. Do I have the length of the hypotenuse? Don't have, man. Have. Can do it. Because why? I have AB one. Once I have the vector AB, don't tell me that you cannot find the length AB. Agree? So what I want to do now is this. Spend more time because it's really a revision. Do both ways now on your thing. Really. You need to know these two ways. And then you decide which way is the most natural way to do. My advice, I always use the dot product because I just want to train my mind to see the projection. Okay? So you understand what I'm trying to say? Do both ways. Okay, class. First, do you know how to get AB, right? I got OB, I got OA, AB come already, Do you understand the AB cross that vector give you the orange color? Oh, which vector? This vector. This vector is the normal one. Yeah. Okay, if you cannot see the cross, okay, never mind. I cannot see the cross, it's cool. Okay. Can you see projection? AB project onto the normal, can see? Which give you what length? The blue one, agree, the blue one. After I get the blue one, can I get the orange one? Can. I need one more length to help me out. AB length. Then use Pythagoras theorem. Agree? Okay, do both ways. You should get the same answer. Do it. You have to go through once. Then you know which method will be natural to you. Use that method for the rest of your exam. Okay? So again? The idea of the cross method is this. I have B here, I have A here. For the rest, please do it. I want the projection of AB onto the plane, which is this length, agree? But I must emphasize this. For planes, right, I will only play with the normal. Understand? So if I only have the normal to play with, my first question will be, now I have AB. I only have the normal. Do you agree that I can only basically do this projection? Agree? So if you can see this projection, fine, go ahead. After I get this projection, how to actually get the thing that the question wants? Pythagoras theorem. You know what I mean by Pythagoras, right? Class, can? Guys, ready? This one I think I do both. Listen up. You have to follow me. Do you agree that these questions, basically, if I do the long way, I am going to find the reflection point A prime? Well, listen up. Any reflection questions, I don't care whether or not it's a point about a line, point about a plane, or any other thing. One thing you always need to go and find. The foot of perpendicular, no matter what. Later I will show you. So in order to find A prime, I have to go and find this foot of perpendicular of A onto the plane. After I find this perpendicular, A prime will come out. Understand this? Yeah. Then after A prime come out, you will be able to find the equation. Very simple already. Because you have BA, you have BA prime, the equation of plane can come out. Make sense? Okay, I'm not going to solve the question directly. I'm going to use this question to tell you how to find reflection. Is this fine? And so far? Okay. But then, how to find the foot of perpendicular from a point to a plane? Okay? I am going to show you the way that I like. The way that I like is, I am going to get the line AF. Do you know how to get the line AF? Look at my picture. What is the equation? Minus 7, tan 3 plus C 1 minus 5, 1. Agree? Yeah, the direction. Because why I know the direction is 1 minus 5, 1. Oh, by the way, you know where this 1 minus 5, 1 come from? I anyhow come out 1. No, right? Yeah, do you agree it's the normal to the plane? It's just that I take away negative sign. I don't want to deal with so many negative signs. So instead of minus 1, 5, minus 1, I want minus 5, 1. Okay? Okay, so after I form the line AF, actually I haven't found the scalar product form of the plane first. Okay, what's the scalar product form for the plane? I think is class, help me to find this answer. Minus 25, minus 24, minus 25 plus 1. Okay, yeah. Yeah, equal to 0. Good. Actually, it must be equal to 0. You know why? When I say equal to 0, I already know that my answer is right. You know why? Because just now, remember like half an hour ago, I did say that the origin lies on this plane, right? Remember? 0, 0, 0. And if the origin lies on this plane, this number is 0. Make sense? Okay. A lot of things will start to make sense. If not, okay, never mind. So this is the equation. So how to actually get the full of perpendicular? Do you agree that I just let this newly created line to sub it into the equation? Correct. First, you know what I'm doing. Pause. Can you see what I'm writing or not? And you all have that face means that like burn out already. That I haven't finished question 1. Am I correct? Do you know what's my target? Okay, let's talk about target. What's my target? Find C. Then after I sub C to the line, do you agree that I get the point F? Guys, agree? So hey, when you eat, don't eat so loud. Minus 7 minus 50 plus 3. Wow, what's the answer? Help me out. Minus 54. Plus 27C. Oh, nice. So C is 2. Correct? Awkward silence here. So OF is what? Guys, give me the answer. OF. Yeah, sub lah. I'm waiting for you all to sub for me. Come on. You're all sitting, I'm standing. My back hurts. Come on. Minus 5. Someone is laughing at my back hurts. Thanks. Yeah. What? 0. Good. Why? Can? This one? Why is it 0? This one? Origin on the plane? A number? Origin on the plane? No, not on the plane. There's a hidden condition on this number, but you need to do some adjustment. This one is more advanced. When I come to that question, then I'll talk about it. But if it's 0, means that the origin is on the plane. That's it. Makes sense, right? Because any point dot the thing will mean that you're on the plane. If it's 0, means that origin is on the plane. Okay. Hey, class. So after I get OF, right? Do you know how do I get OA prime? How? I will use what theorem? Don't tell me that after I get OF, I go and use A prime F equals to FA. No need, no need. Immediately go for ratio theorem. Why? Do you realize that this is also a ratio? Agree? It's a ratio. 1. Reflection, the length is the same. Which means that OF is equals to OA plus OA prime divided by 2. Make sense? And once I have OF, I have OA prime will come out. Understand? So, to do reflection is a combination of finding full perpendicular plus ratio theorem. Understand this? Yeah? Then from there the answer will come out. Is this fine? Now class, I'm not going to finish this question now. After you get OA prime, you will be able to get the equation of plane. Agree or not? Agree? So the last part, I leave it up to you. Is it okay? Go back and do. Because I want to talk about extension of reflection type of questions. Is this fine? Okay. Ready? I'm going to start a new note already. Copy down. So I listen. This one I leave up to you. You will get OA prime. Then from OA point, you get the equation of the plane pi 2. Okay, pause. Yes. Yes. Can? Okay, good. Hey, by the way, do you know how to get the equation of plane pi 2 or not? They never ask for scalar product form. Do you know what you do? Just a point 2 vectors. And what 2 vectors will you use? BA prime. Correct? Actually, what is the shortcut? Do you know? One of the vector you already know already, even without A prime. You know what is that vector? The normal. Make sense? Yeah. So this is why I say I'm not using shortcut. Because I'm using this question to tell you how to do reflection. Technically, I don't even need to find A prime to find the answer to this part. Make sense? Because I have the 2 vectors already. What are the 2 vectors? A, B, and the normal. Done, settled. Choose point B or point A. Done, settled. My question is settled. This is why it's a 3 marks question. Understand? But I'm just using this to tell you how to find reflection. Fine? Okay, all? Guys, I need some. Okay, all? Okay, class. Ready for extension? How to act? Yes or no? No. Don't what? No. I don't have n. I don't want n. N is very difficult to find. I just find the 2 vectors on pi 2. You know how pi 2 looks like, right? Hey, class. Okay, class, can I finish this question now? Listen up. Already on. Just now when you're doing your working, you have AB, right? Answer to AB is minus 17 minus 5, 46. Is it correct? Okay. The shortcut to part 2, do you agree that the answer is just R equals to, okay lah, choose anyone I like. That's the answer. To the plane 2, this is plane 2. Do you know why? Because if the question tells you that plane 2 contains A, B, A prime, do you agree that it's like that? Yeah, imagine plane like this, then one plane like this. Can Then do you agree that if it's like this, what is the 2 vector that's parallel to it? AB? Make sense? The normal? Make sense? Agree or not? And I think you can even answer the very last part. What is the angle between pi 1 and pi 2? Yeah, 90. Makes sense. 90. Agree? So can you see? There's a shortcut. But I'm just basically using this question to show you how to find reflection, which is actually extra. Understand? So remember, the method I show you is not the standard way of solving this question. Understand? I'm just using it to tell you how to get reflection. Okay? Is it okay? Class, can I move on? Okay. So question 1 done. But before we take a break, this is one thing that I want to show to you. Extension of everything. Listen up. Class, I have a line like this. Can? Okay. Usually the picture that I will draw is look like that. Let's say that I have another point called phi 0 minus 2. My question is, do you know how to find the foot of perpendicular of this point to the line? There are 2 methods, correct? The first method is what? The first method is, I'm going to call this A, I'm going to call this P. I'm going to find AP, which is equals to 4, 0, 0. Is it correct? Okay. Then do you know my strategy? I'm going to find AF. Any advice how to find AF? How should my working look like? Good, projection. I heard projection. So, you know the method. Tell me the details of the working. 4, 0, 0. Dot with 1, 2 minus 1, over square root 6, right? Because I need the head, right? Then, because remember, we are finding a vector. Bracket, very good. The same thing, 1, 2 minus 1 square root 6. Agree? Which means that the answer, I think, is just 4 over 6, 1, 2 minus 1. After you get AF, do you agree that OF can come out? Agree, right? This is the projection vector method to find the foot of a perpendicular. Is this fine? What is another method, which is the preferred method by me? The other method is, I know that OF look like this. Do you know why I immediately tell myself OF look like this? Because F is on the line. I repeat this very important sentence. Any point on the line, the position vector takes the expression of the line. You understand what I'm saying? Okay. So in order to find OF, do you agree that I just need to find lambda? So how to find lambda? The way that I do is this. This triangle is very useful to me. Meaning, PF dot with, may I guess, dot with, look at my picture. AF is this one, PF is this. This is extra, this is extra. PF is this. Dot with what? No, not AF. I don't have AF. I don't have AF. But I have one thing on my picture. Oh yes, what is the direction vector? Correct. 1, 2 minus 1 must give you 0. Agree. Can I find PF? Yes, right. Because I just use OF minus PF. Then the dot product will allow me to find what? Lambda. From the lambda, OF comes. Then my question will be this. Which is the method that you will prefer in exam? You need to have one. Eventually master both. But you need to have one now. Okay? So now decide which method do you think in exam situation you will immediately recall. Okay? As I said, this is my preferred method because working wise won't make mistake. Understand this? Okay? Julie, okay? Okay, cannot. So answer one time say. Again? No, I give this equation. Yeah, from this equation, I should be drawing this picture, right? Isn't it so? Yeah, this is the equation on the line. Sorry, I didn't say that. This is the equation on the line. I just start off from this equation line and start to tell you things. Is it okay? So far, so good? Okay, The extension part, I'm not going to write down a lot of working. You have to write down yourself. So listen out very carefully already. Ready? Okay. Can I move on? Understand? Put a perpendicular from point to line. So I done put a perpendicular from point to a line. You all need to now have one basic method to do. I also go through with you how to find put a perpendicular from a point to a plane. Remember just now? Okay, so go through again. Put a perpendicular from a point to a plane. P, F. How to find this F? Listen up. First method, form the equation of the line PF. Can right? Because I have P, I have the direction vector. Where do the direction vector come from? Where? The normal to the plane. Agree? Then from there, I use this line intersect the plane. Then this put perpendicular form up. Agree? But can I use projection vector also? How? Do you agree I should be able to find a point on the plane? Because with the equation of the plane, I can just come up with one point. Let's say that this equation of the plane is 1, 2, 3 equals to 3. Okay? This vector is 1, 2, 3, right? What can be A? 0, 0, 1, agree. But can I use 3, 0, 0? Can, go ahead. Any point is okay. So after you get the point, what do? Join. You have AP, right? But why I want AP? What is my idea? With AP, what will do? I'm going to project onto where? Normal. But I'm not only getting the projection line, I'm going to go for the projection vector. So how to get the projection vector? Do you agree that it's AP dot who? 1, 2, 3, hat it, right? Correct? 1, 4, 9, 1, 4, 5, 14, I think. Then bracket 1, 2, 3, square root 14, right? Agree? Take note, I use AP, I project. What vector am I getting? Okay, up. Yeah, up. So what vector am I getting? FP or PF. Very good. Direction matters. You get FP. From FP, can you get F? Yes. But this method is tricky. Why? Direction matters. Because if you use PA, project, what vector are you getting? PF. And this is one kind of mistake for students who use this method. Direction matters. And you said just now the line method, direction doesn't matter. Understand this all? Yeah. And it's 10:30 and I only have one question. Oh my god. Today can tahan until 1. Okay, never mind. Let's see how far we can go. Okay, so extension now. Listen class. Extension now. So if a question give you an equation online, give you a point, ask you to find the reflection of this point. Can find? Strategy? What's the first thing you need to find? Foot or perpendicular. Totally agree. Then from the foot or perpendicular, you use ratio theorem to find this reflection point. Agree. And foot or perpendicular how to find? That's how I show you already. Make sense? Extend. If I have another line, I want to reflect the green line about the blue line, which the answer should look like this. Agree? How to find? Right now, do you agree that this point is important? But can I get this point? Possible, right? Because this point is basically the intersection between who? Green and blue. Do you know how to get intersection between two lines? Can, right? GC way. Make sense? But after I get this point, how to continue so that the light blue color line can come out? Well, do you agree I can get a point on the line, the original? Can I reflect? How to reflect? Go perpendicular, ratio theorem. After I get this point, will the blue line come out? 2 points, the line will come out. Make sense? Okay. But is this the only situation? Because what if the situation like this? This is a mirror, but the line now look like that. Or this is actually a simple case. Because if I reflect the line, I know one thing already. I know one thing about this reflected line. The direction vector is the same. So there's only one thing that's missing. What's that one thing that's missing? A point, right? But how to get a point? Yes, get a point, do a reflection. And then you're done. Can you see that the whole idea now that is some similarities is always about foot perpendicular and reflection? Make sense? Yeah? So okay, extend. One more. Now go to plane. I already go through with you how to find the reflection of a point about a plane, right? How to find the foot perpendicular and then find the reflection point. Agree? So what if now I have a plane, the red color one. I have this line. I want to reflect this line about the plane. The reflection line, which I'm going to use green to orange. Do you agree I look like this? Then tell me your strategy, how to find this equation of this reflected line. What is important first? Oh, sorry? The intersection, right? Intersection of who? The line and the plane. This one. Correct? Can find? Can find, right? Have the method in mind. After that, get a point. And reflect. How to reflect? Get full perpendicular. Agree? But you should know by now. This is no. not only a situation, right? I can have this situation, right? But this situation is better. Why? The reflection line, the direction vector is the same. So I only need the point, and I just reflect the point. Done. Yeah. Last one, which is the most advanced one. Okay. Black plane, green plane. Reflect green about black. Do you agree the picture should look something like this? Well, you can see. In this sense, what's important? What you go and find first? Okay, the what line? Line of intersection, very good. Which is this one. Correct? Do you agree that this line of intersection will also on the pink reflected plane? Yeah. Then I need one more thing. Make a guess. Choose a point here on the green, then what do? Reflect. Then it will be on here, right? If now on the pink color plane, I have a line, I have a point. Do you agree the equation of pink come out? You know how? Go through. If the pink color have a line equation, have a point, how to get a point? A point is there. But how to get the two vectors? Direction vector of the line. The other one, how? There should be a point on the plane, right? Line, right? Then join. Understand? Can you see there are similarities across everybody? Then of course the last one is plane about plane. Plane about plane, do I need to explain? Only, right? Because you reflect normal state. So the only thing I need is what? Reflect a point. Understand? So all the reflection questions you should know. Is it okay? Okay, I need to take a break. 3 minutes. Hey, okay, let's start. But there's one thing I have to mention. Listen up. Guys, this is the main issue. Hey, class, all listen here. Listen. Ready? Listen. If I call this A, I call this B. Ready? Technically, the name to this line is line AB. Make sense? Make sense? The equation, by now, you should know that I pick a point, I say a lambda, I do a directional vector. You know that 3 minus 2, 0 come from where, right? Plus come from where? B minus A lah, AB lah. A vector that's parallel to the line. All agree? But I have a question. Do you agree now you have this expression? Expression. Where do this expression come from? Is the expression of the equation of the line. Agree? My question is this. Do you agree OA is equal to this for some lambda? Because by definition, what does this expression mean? I already say that sentence. It represents any point on the line. Projection vector wise. Can I write OB as this expression? Yes. But can I write AB as this expression? No. Although it's called line AB, right? But AB, the vector, cannot be written in this expression because why? AB is not a point on the line. A point, when I say a point, it is always with respect to where? Origin. Which means that this expression, do you know what it actually represents? It actually represents this. Imagine O is here. It represents all these vectors. It doesn't represent the vector that's parallel to the line. Understand? That means when I say the equation of the line, it's actually the vector with respect to the origin. It's not this. It's all this. And that's the reason why the sentence stands. Point on the line. When I say point on the line, it's with reference to the origin. This is the key thing. Because every time you tell me line AB, right, in your mind you always tell yourself, oh, this is the expression AB. No. only the direction vector is parallel to AB. That one, yes. But once you add the point inside, you are creating all these vectors. Understand now? Okay? Yeah. And very nice. I already only done question 1. Very good. Good job. Okay. Ready for 2? Let's see what 2 have. Class ready? Okay, Can? Question 2. Okay, let's start. Okay, for question 2, you have this fact: E lies on BA produce, E lies on BA produce. This is always a picture. If I read the question, BE is 3AE. So usually, how do I actually find the ratio? I let AE to be 1. Then BE whole thing is 3, so this one is 2. Is it okay? And so far? But here comes the question. Why I select this question is because it actually lets you to do dot product. Okay, listen up. Class, what is okay, I need OC dot OD. Anyone can tell me what OC is inside the question? You read on. OC. A plus B, very good. OD? A minus B, very good. Do you know that dot product can open up? You know, right? Can open up like this, right? Later I'm going to show you an extra example to create more things for you. I'm not going to finish all the questions today. Oh my god. Is it okay? I open this up like this. Cannot. So do you agree that something cancel out already? Because B dot A dot B, they are same. So these two things cancel. Make sense? Now, my question is, A dot A means something special. Do you know what it is? Mod A square. Do you know why mod A square, right? Don't know. You know A dot B. Yeah. You know A dot B is like this? By definition. So A dot A is actually mod A, right? Agree, right? Then theta is defined as the angle between the two vectors, right? And what's the angle between vector and himself? 0. So giving you mod A square. Okay? So this one is equals to mod A square minus mod B square. But if you read the question, do you realize that the question tells you OA, OB equal? Read the question. OA, OB equal? Without the vector means what? Do you know? Length is equal. If length is equal, do you agree that these two values are the same? Equals to 0. So what is telling you? OC, OD dot equals to 0 means OC, OD perpendicular. Okay? Okay, but there's more questions. They actually want you to give a geometrical interpretation of the figure OACB. So let me draw a simple one first. OACB. Okay, now I know that OA and OB same length. Can? Then I know OC dot OD is 0. But where is D? Class, do you know where is D? Guys, do you know where is D? A is here. B is here. Do you know where D is or not? You read out D is defined as what? A minus B ma. So A minus B, you know where it is or not? A minus B is here. This is very bad. Erase. Let's start. This is O, A, O, B. Can? Where is C, guys? C is A plus B. Where is C? You're right. C. Alright, OA plus OB here, correct? Where is D? A minus B. Here, right? Correct? Then you need to give a geometric representation of OA, OACB, correct? But the thing that you know is OC, OD, right angle. Cannot. So how do you actually know the geometrical representation of OACB? I thought I just now showed OC dot OD equals 0. Whenever you have a dot product equals 0, it must be imprinted that the two things are perpendicular. Confirm one. This is always what they actually test you on. Can? Okay, so start. What is the picture? How does the picture look like? Okay, someone is doing the Ultraman. Hi. 咸蛋超人. So how? What is the picture look like? I'm not going to give it to you. Parallelogram. No lah. At least you should tell me that it's a rhombus already. But this is not just a rhombus. It's a square. Okay, how am I going to say this? Okay, OA is like this. OB is like this. OC is like this. Okay, I draw it like this. So C is here. Can? So the picture that they want me to find is OACD. Agree? At least, do we agree first? Set rhombus already. Because length of OA, OB is the same. The only thing is that, can I talk about more things about this rhombus? Make sense? Okay. So what do I actually know? I know that OC and OD, which is A minus B. Do you know where A minus B is? Okay, A minus B is somewhere here. A minus B, correct, somewhere here. But do you agree that it's the same vector as this? Is it correct? Wait, no. What am I saying? Wait, this is. Okay, let me draw this here. D. So OD is here. Can? OD is there. Is this fine? Okay, pause over. Can? Can, pause over. Can. Okay, here comes the part ready, ready, Claim. First claim. OC, OD, same length. Why? Because OC is OA plus OB, like that. OD is OA minus OB, go down. It's different direction, but same length. Agree? Agree? So not only same length. Do you agree that A is the midpoint? A is the midpoint. So do you agree that this whole thing will actually form a right angle triangle? Right angle is confirmed. Do you agree right angle is confirmed? Right angle confirmed because I showed you already. But A is the midpoint and these two lengths is the same. This means that this one here will be 90 degrees. Okay, the two lengths must be the same. The two lengths must be the same. Okay, then I use the midpoint and cut up. Do you realize that it will be the midpoint? Or how should I say? This one is 90 degrees. Provided same length, okay? Different length, not true. Understand? So one is 90 degrees. This means that this whole rhombus is actually moved such that this angle 90 degrees, meaning the geometrical figure is a square. By the way, in the question, in the exams, you just have to state the geometrical shape. Nothing already. You just need to state the geometrical shape. Okay? Can? So you just need to say that it's square. But how to actually explain the square? Something like this. So you just draw. Can? Sometimes you can also make a guess. Rhombus. Then they say state the geometrical shape. Then be a bit daring. Must be a square. Exam smart. Okay, this is what exam smart. Can? Okay so far? Or you still need some explanation about how this works? Only, right? Only, yeah? Okay, here comes the part. Great, I have this one with me. This is a good time to do this. Yes, patient, any problem? Can you just ask why OC equals to OD? Because to create OC, do you agree that I use this vector and this vector and then this one, right? But this vector is just going the opposite way. Makes sense, right? Going the opposite way. So this thing, when I draw it, do you agree that these two lengths must be the same? Because I'm doing same direction. It's just like opposite. This means that, can you see that these two triangles are congruent? If the two triangles are congruent, it means that the length are the same. Can? Make sense? Okay, can so far? Guys, yeah. Okay, area, yeah, area. Here comes the area. Do you know how I immediately get area? Half modulus. Any two sides you love. You want OA cross OE? Can. You want OA cross AE? Go ahead. You want AE cross OE? Fine. Any two sides will do. Understand this? This is the first thing I want to tell you. To apply the formula, it will be two side cross mod take half. Can? Okay? But if you have parallelogram, do you realize that you have no choice? Because for parallelogram, right, technically there's only two sides. Therefore, the parallelogram is just A cross B form. That's it. Triangle three sides, so you have more choices. But it's just any of the two. The answer are always the same. Okay? Here? Okay, so to help me, I will just choose OA, OE. Is this fine? OA I have already. Do I have OE? Well, to find OE, I think I need to use this picture to help me to find OE, right? So let's do a quick one. OA, OB, divided by 3. So 3AB plus 2OE. So 3A minus B divided by 2. Is it correct? Double check for me. OE is like this. Is it correct? 3A minus B divided by 2. Awkward silence, I will have to check. Okay. So this is how we do it. Half A cross, what's the answer? 3A minus B divided by 2. 3A minus B divided by 2. Is it okay? Okay, first thing first is, every time when you do this type of cross product, can you actually take out all these numbers? Okay, can you see that there's a half? So take out the half. So you're left with this. Can? Then you can open up. Now, how to open up? Do you realize that this one is like A cross 3A? Now, every time you have A cross 3A, right, the numbers just put it to one side, giving you 3A cross A. Understand? Then if you have this, it's just minus A cross B. Is it okay? Now, what is A cross A plus? No. A dot A is more A squared. But when you have A cross A, you have nothing. Because the cross product formula is sine. Sine 0 is 0. So A cross A is 0. Which means that this answer is just like this. That will cause a negative sign. Because of the modulus, you can just remove it. Can? Is this the answer? 1/4? Cannot. Is this fine? Okay so far? Okay, 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 let's do something more. Okay? Extra. Ready? But this extra, okay? plus, listen up. The vector OC is A plus B. Vector OE is 3A minus B. Vector OD is A plus 5B. My question, I want the area of this triangle. How will you find it? Okay, your strategy. It will be half modulus choose CE cross. Fine. You choose these two. Let's go for these two. So what is CE? Yeah, OE minus OC. Give me the answer. Fast. 2A minus 2B. Make sense? Okay, let's put it down. 2A minus 2B. Cross. Minus CD. Minus 2A plus 6B. Oh, OD minus OC. Sorry. OD minus OC. My mistake. Giving you what? This is ugly. Yeah, let's do this two lah. Two. Let's make this two. I don't want the A to disappear. Fine. Sorry. So answer is A plus 4B. Okay, A plus 4B. Is this fine? Okay, so what I'm going to do? I'm going to open the things up. Correct? So how to open up? 2A cross A. Can you see that I put the numbers to one side? Then this one is 2A cross 4B, right? Is plus 8A cross B. Numbers to one side. This one? No, I will see this as minus 2B cross A. Cross have direction inside. You have to be super careful. The last one? Minus 8B cross B. Make sense? But there's something that is going to disappear already. What are they? Because A cross A, B cross B are 0. So the answer is 6A cross B, therefore the answer is 3A cross B. 8 minus 2 6 Then 6 pull out 3 No. Why? Because they are not the same technically. Minus 2B cross A is plus 2A cross B, remember? Therefore this answer is actually 5 more A cross B. Dot can switch. Cross switch got negative sign. Understand this? Yeah. Okay, so let's go on. I'm not going to finish everything. Find the length of OE onto line OB. Length plus what is the length of projection? How to find? How to find? OE onto line OB. Yeah, it's projection so something dot something and it's actually something dot something hat So OE dot OB hat modulus, right? Because I only need the length. Make sense? Okay, what is E? What is E? I just now forget already. What's E? 3A minus B over 2, right? Dot B hat Okay lah, how to handle the hat? And you are staring at my screen and you are not reading the question. Over 3, very good, because what do the question say? The length of B is 3. So what will you do to this 2 and this 3? Take out, very good. And it's a multiplier. So you only left with 3A minus B dot B. Make sense? Okay, so 1/6 3A dot B minus B dot B. Agree? Okay, oh? Okay. What is b dot b? Mod b square. Mod b do I know? 3. 3 square, 9. Happy. But a dot b, jialat, don't know what to do. Do I have information to settle a dot b? Why? By definition, is mod a, mod b, cosine theta, right? Theta is defined as the angle between a and b, right? So picture wise should look like this. I need this angle. Do I have this angle? Am I given? Yeah, 60 degrees. Correct? Which means that this one is just 3 cosine 60 degrees. Make sense? Cosine 60 degrees is how much? Half, right? So this is 9 over 2. So minus giving you 1/6, 9 over 2. What is the answer? 9 over 12, 3 over 4. Is this the answer? Yes. Okay. Understand? So it's always searching for information. Okay. What's the time now? Okay. How about this? Yeah. Eh? So I have another 3, right? Oh, thank you. Then why my answer is right? Scary. Oh yeah, because it's still the same. Yeah. Okay, it's still the same. It's just positive. Can? I think my brain also got fried already. Sorry? What? What did you say? Time to stop. Sometimes I just breathe in, then I can go on for another 1 hour. Let's go. Yeah. I breathe air for energy. Oh, this. Oh, my brain also get fried. But it's good. When our brains get fried, it recovers, it becomes stronger. Yeah. Next week, hopefully more turn out for the Saturday practice. I need to fry more brains. Yeah. You ask those that came, you can see that they are like having the aura becoming brighter already. Right? Okay, question 4. Let's do question 4 first. I skip question 3 for a while. Okay? Okay, question 4 first. Okay, let's do question 4. Okay, class, for question 4, for those who haven't done it, can you now do it? The plane pi 1, pi 2 intersect line L. How to actually find the vector equation of L? What is your job? Class, what is your job? Intersection between two planes. How do you solve? What is the method to solve? GC. But to do GC, I need the equation to be in what form? Cartesian form. Is this in Cartesian form? So how to change it to Cartesian form? I need to go through scalar polar form. To go through scalar polar form means that I need the norm. No choice. So let's go. Okay? Okay, I do question 4, I skip question 3 for a while. So normal to pi 2. Is the answer 1 minus 1 1? So nice. Yeah, double check. Yep. So pi 2 is 1 minus 1 1. Sub in a point 2 0 1 3. So the two equations that you need to solve for me. Someone take out GC now. So what is the equation of the line? What does the GC give you? Yeah, I think all the brains fried already. All become fried egg. Yeah, when the face start to like shrink by 10%. Not bad, Xishan still smiling. Good. Equation online now. If you can't get it, Guo Xuan is the time to actually help you out. Guo Xuan, I don't really hear you speak before. Hi. A lot of shy guys in your class. Oh, that's Yu Jie, correct. Yu Jie, right? Yeah, I always mix up. Yu Jie, answer. Yeah, do lah. Yeah, come to think about it, there's two prominent people from class not here. Never mind. Suddenly realize. Must be confirmed. Anyway, yep. I will ask them next week. Yeah, you go and look at Gang Zhe's tutorial. You look at the top right hand side. There's always one drawing of a bear, and the bear is waving his hand. You can go and see it. This time round, when he handed out his tutorial, I write there. Are you waving to a special someone in class? Yeah, I know. It's okay. Now I will keep this part so that when Gang Zhe go through the lecture, like, wow. Okay. Now, since I'm not saying the other name, it should be fine. Answer 300. Is it correct? Hey, is it correct? Okay, good. This is the answer. Is the answer what? No, man. Don't tell me it's not the answer. It is. It's the same answer I give you at the back of the answer key. It is. Take note. Negative sign for the direction vector is fine. Okay, class, listen up. Here comes the part. Okay, this is the part that a lot of you have problem with. So are you ready? Ready? Okay, listen up. This one, because A level actually come out, so you need to know what to do. Listen up. Can you see that they say that the plane have no point in common? What can be said about the value ABC? And ABC is actually contained in pi tree. Agree? Now, this is a strategy. Write it somewhere. Every time when you actually look at three plane intersection, it is impossible for you to keep track of the three planes at the same time. So the strategy is what? Two of the plane, you go and find the intersecting line. Because if two of the plane have no intersecting line, you actually is safe and home free already. Because what? Definitely three planes have no intersection. Agree? If you can see okay, you pick any two planes, then confirm these two planes should have intersecting line. Don't have good long, then the three planes have definitely no common point in common. Done. Don't care. Don't care. Because when you say common, it must be in all three. Understand? So if two don't have, that's it. Settled. Question settled. So come to the point. So two of them have an intersecting line. Okay? Then the question will be this. Do you agree that in this particular question, plane 1, plane 2 have intersecting line? Okay. However, I don't want three planes to have common point. Do you agree that this means the intersecting line of plane 1, plane 2 cannot touch plane 3? Because if the intersecting line of plane 1, plane 2 touch plane 3, we are having common point among three planes. Agree? So if that is the case, then this question can be solved. How? Because if I am saying that the intersecting line cannot touch plane 3, what situation am I having? Plane 3. I look at the equation, it looks something like this, 2AB. Correct? The intersecting line is like this. 3, 0, 0, minus 1, 0, 1. Agree all? So if this line is not touching plane 3 at all, the very first thing I will tell myself is this. And the next thing I'm going to tell myself is this. it totally look like same, right? Like dot dot dot, everything is dot, but it actually means different thing. Where do the first dot product equals to 0 come from? The direction vector of the line should be perpendicular to the normal of the plane. Agree? Because the line is not touching, means that it's parallel to the plane, means that it's perpendicular to the norm. But if you only give me this situation, that is the issue. Why? Because the line can be everything on the plane. I don't want that to happen. So how to make that not happening? The point 300 cannot be on the plane. Which means that when I sub into the equation of the plane, cannot equal. So from here, do you agree that minus 2 plus b equals to 0 come out? B is equals to 2. And from here, 6 not equals to c. Agree, right? But then, this means one thing. Then A leh? Do you have any condition on A? No, right? So A is anything. Because you have no restriction. Understand? Okay. So I extend the question a bit. This is the situation. A anything. C not equals to 6. B equals to 2. They will not have any point common. Correct? What if now I extend the question? I want these three planes have one common point. One common point. So what does this mean then? This means that the intersecting line of plane 1, plane 2 will touch plane 3 once. And to let the line touch the plane, right, you only need to have one condition. The condition is done. Why? Because if the line is not parallel to the plane, confirm one second. This one will lead to one common point. Is it okay? But what if now I extend more? What if now I want all three planes to intersect at a line? This means what? The intersecting line between plane 1 and plane 2 must totally be now on plane 3. Then do you agree that the first working is the same? But the second working should be 300.2ab now equals to c. And you cover everything. Strategy, okay? Always let the intersecting line between two planes, so-called indirect interval.
Yeah, 6届 Timothy ending, just stay out.
Oh, because for one common point, do you agree that to actually have one common point between three planes is basically the same as saying the intersecting line between the two touches the third once. And actually, because this is the thing that you only want, the line touches the plane once. The only thing that you just need to make sure they are not parallel. Because if the line is not parallel to the plane, touch. It doesn't even need to be perpendicular. Like, just tilt it a bit, it will touch, and you will touch one point. And that's the reason why I just need the dot product 1 equals 0. I'm done. I don't even need to know anything else. Agree? Yeah. So this is how you actually do it. Can? Okay. So yeah, more. Part 3. Plane contain the origin. Find the Cartesian equation of plane such that plane 1, plane 2 are reflection of each other in plane. Oh, good. Guys, how to do this then? Sorry? The plane pi contains the point origin. Find the Cartesian equation of this such that plane 1, plane 2 are reflection of each other in plane. You read this thing. My question is this. Who is the mirror? Pi, right? Do I know about anything about this mirror? Well, I know that the origin is on it. But I actually know one more thing is on it. The what? The line L. Why the line L must be on it? Because the picture looks like this. Plane 1, plane 2, which actually intersect at line L, they are reflection of one another in this mirror. So how would the mirror be at? It's like through the middle, right? But the one thing that I know about this mirror is it has the origin. Make sense? And the best part, I know one more thing about it. It actually contains line L. Wow, stun. Wait ah. Okay, this is plane 1. This is plane 2. And we agree that plane 1, plane 2 intersect already because in the very first part, we are asked to find the intersecting line. Now imagine now, you are saying that there's a mirror that when you put it in, these two planes will be reflection of one another in this mirror. Where's the mirror? Through the middle? Agree through the middle? And if it's through the middle, do we agree that this mirror passes through this intersecting line? Which means that this intersecting line is on the mirror, plane pi. But one more thing I need to know. I also know that the origin is on it. So with one line, 1 point on it, can you give me the equation? You can. Okay, first thing first. Do you all agree that the mirror contains this intersecting line? This one can agree? Agree first? Agree? Okay, so if you agree with this, the very first thing I will draw is, I draw separately. This mirror will have line L. Agree? And then, this means that you will have 3, 0, 0, 1, 0, minus 1. Correct? If I read the question good, they actually tell me that the origin is on it. Agree? Which means that, do you agree that the equation of this plane can be written as this? 1, 0, minus 1. And then this is the vector that I can use. B 3, 0, 0. Agree? Then from this vector equation, I go and find the scalar product form, then the Cartesian. Because no choice on this question wants Cartesian. If the question never asks anything, this is my answer. Can so far? Okay. Can you work it out by yourself? Understand? Okay. Okay, let's go 5. Okay, after I do 5, right, then I take a look at the list of the things that I showed to you and see what are the things that I haven't covered yet. Then I just give you simple examples. I don't think I can cover every question today. You all are brain fried already. So go back and I think 6 I also have to say. Okay, 5, 6, 8, 5, 6. I aim 5, 6 to finish by 12. Well, you cannot finish by 12, then go on. Oh. I can go all the way to 2. You gain? Yeah, that's the thing. Do you need to take a break? Okay, I think I can continue now. Let's go. Class ready? Blah, 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 blah. Okay, guys. How to verify that A is on plane 1? Sub A in. So A is what point? 1, 0, 1. Dot with 1, 2, 1. 1 plus 0 plus 1 equals to 2. Verify. That's it. Can? Okay. Okay, I need you to think. Find the distance between plane 1 and plane 2. Okay, here comes the part about distance between planes. First thing first is this one. Let me go through this. One more. No. It's all about distance. Now, if I have a point, I have a line. What is the way to find the distance between this point to this line? Give me the strategy. Come on. By the way, if I give you a line, right, you should have a point on the line and a direction vector. Make sense? Because I will give you the equation. So I will have a point, I will have a direction vector. So if that's the case, if I give you another point called B, how do you actually get the distance of this point to this one? Okay, you are going to form AB, the vector. After you form it, what do you do? Project onto the line. Can. You project onto the line, which means AB, this vector AB, Okay, dot what? D hat. Good. After you project, is this the length that you want? Then how do you get the length you want? 5.0. Good, good. But of course you know there's another way lah. But if that's that way very confusing, don't do it yet. You need one way first. Okay. How about the distance from a point to a plane? Okay, if I give you a plane, definitely normal, no, confirm one. So how to get the distance of this point to this plane? Strategy. You pick a point on the plane. Very good. Why do you want to pick a point on the plane? Because you want to connect. And because after you connect, I think you will see how to find this distance rate. You will use this vector, project onto the normal. Will the answer be directly to you? Yes. Can you see the difference? Yeah. But when you talk about distance between line and line, it only makes sense when they are parallel. Because if they are not parallel, there is intersection is 0. Understand? Okay, by the way, skewed lines distance between skewed lines is not in your syllabus, so don't think about it. Okay? So parallel lines, class, how to find it? Strategy is same. I look at my picture. Do you agree that there's a directional vector? Do you agree that I can pick 2 points, respectively on 2 lines? Do you know what I'm going to do already? I'm going to join them up. Then I'm going to project onto where? Anywhere lah. You want line, 2, fine. You will get this distance, right? After you get this distance, you get this distance. Make sense? Agree? What about line and plane? Again, only makes sense if they are parallel. Because if they are not parallel, distance 0. So what is the strategy? Same. Alright. Then what do? Pick a point here. Pick a point here. Join up. Project the normal. Can you see that everything is like the same now? Okay. So then this comes to this point. How do you solve this question? How to actually get the distance between these 2 planes? So I draw the picture. It's like this. It's like this. They have the same normal. 1, 2, 1. This point 1, 0, 1 is on plane 1. I need one more thing. One more point on plane 2. So can you give me a point on plane 2? 0, 4, 0. Good. So what do? You join up. -1, 4, -1. Dot with 1, 2, 1 hat. This will give you a distance. Agree? That's it. So this is the problem. If I give you a solution like this, it's a lot of times very difficult to analyze what it's actually talking about. You need to know the idea. Okay? So it's square root 6, right? Answer? Good. Correct? Is it okay? Okay, then show the acute angle between L and plane 1 is 60 degrees. Do you know how to find the angle between a line and a plane? Guys, angle between line and plane, part 2 already. So part 3, sorry. So it's cosine theta equals to the plane 1 vector normal is 1, 2, 1. The line, what's the line? Line L is parallel to vector j plus k, which means that the direction vector of the line is what? 0, 1, 1. So divide by square root 6, divide by square root, what is this? 2 modulus, which means that cosine theta equals to 3 over square root 12. Theta is actually, you know how much is this theta? Guys, use your calculator now. Yeah, cosine inverse 3 over square root 12. 30 degrees, right? I thought the answer tell me to show 60 degrees. Do you know why it's 60 degrees? Because this question is line and plane angle. Line and plane angle, if you use a cosine, which is the normal angle formula, there is a 90 degree adjustment. The only formula that have no 90-degree adjustment is angle between line and line and angle between plane and plane. Understand? Okay, so angle between L and pi 1 equals to 90 degree minus 30 degree, 90 degree adjustment, 60 degree. Okay, so far? Okay, okay. Okay, you have plane 1, you have plane 2, right? You have a P, right? The P is the point between plane and plane 2 such that the ratio of plane, the point to 1 to 2 is 3 to 1. So P is here is 3, here is 1. Do you agree? That's what the picture is saying. Then, it lies on the plane that's parallel to plane 1 and plane 2. So it lies on this plane. Correct? I need to find the equation of this plane. Yeah? Class ready? This is another thing that you need to know how to play with it. Huh? What do I know about this plane? Parallel to both lah. So this plane here, the equation should look like R dot. Yeah, good. Read the question again. R dot what? 1, 2, 1. Agree first? Okay. But it's not complete, right? Because the scalar product form, I need to know the number. To know the number, one thing, listen, I'm not going to find P. I'm going to do the following. Listen, can you just give me any point on plane 1? Just now you give me already. Let's give me another one. It's simple one to do with. Anyone? 0, 1, 1? Huh? 0, 1, 1. 0, 1, 0. Good. Give me another point on plane 2. Anyone? 0, 4, 0. Fine. Good. 0, 4, 0. Assume it's here. Can? Do you know what I'm going to do? I'm going to join these 2 points up. Do you agree that this line will passes through this pink color? I know that point. Because why? The ratio here is still must be 3 and the ratio here still must be 1. Which means that I can use ratio theorem to find this point, put it in, answer count. When I say that the ratio is 3 to 1, right, it need not necessarily be perpendicular. It can be slanted. And by similar triangle, the ratio still stay the same. That's the reason why I can pick any arbitrary point, join it up, and then use ratio theorem to find. Understand? Okay? So try it, very fast one, the answer will come out. Okay, do it now. Come on. Very fast one, this one. Yep. Yeah. Confirm. Must guarantee. With satisfaction guarantee, yeah. Yeah. Similar triangles one. The similar triangles. The side and the hypotenuse ratio is always the same. Okay? Hey, come on, see whether you get 13 over 2. Hey, do you all get the answer? Now after this, I will just go through the last question. Last question, that's reason why, because the 3D diagram, I need to tell you how to approach this question. After that, we call it a day. Okay, I think your brain fried. I also going haywire already. Hey, do you got 13 over 2? Oh, good. The next say yes. Answer? Hey, please do lah. If not lah, then go back. You either throw it away, burn it, or whatever it is, right? Eat it. 13 over 2? Okay, class, listen up. Last part. Okay, last part, ready? This last part. Okay, listen up. If I say state with reason the number of point intersection between pi 1, pi 2, pi 3, how many possible answers can you give me? 3 types of answers. One of them, no intersection. One intersection. No, it's not 2 intersections. Super many intersections, which is intersecting on a line. Yeah, line. Understand? So only have 3 answers. 0, 1 point, infinite number of points, forming a line. Usually you are not talking about the same plane, so it's okay. Okay? 3 things. Can Start. Okay, if I say the number of points between 3 planes, there is 3 types of answer, right? The 3 planes don't intersect, 0. The 3 planes intersect a point, 1. The 3 planes intersect a line is possible, right? But if it intersect a line, how many solutions are there? Many, infinite. Understand? Okay. Who can tell me how many in this case? Many. You have to read very carefully. Okay, I read. Agree line on plane 1. Yes or no? You cannot just stare at it, you have to stare at your question. Is line on plane 1? Where does that come from? Where? Line. Is it a line on plane 1? No, line on. Wait, I have to read also. L is actually on plane 3. Okay, line is on plane 3 only. Okay? Then, line is on plane 3. So, guys, yeah, everybody is like gone already. Class, do you know what's the answer? 0 leh. It's 0 leh. Do you know why is it 0? Plane 1 and plane 2 are parallel, they don't intersect. Forget about it. Yeah. Yes. You're all stunned again. Yeah, people are going mad. Okay, people are going mad. So I think later question 6, I'm just going to go through with you. Or else, really, people is going to draw out a 9 and QB. Listen up. The question asks for plane 1, plane 2, plane 3, whether there's intersecting point, right? Do you agree that 2 of them, plane 1, plane 2, based on the question, parallel? They don't intersect. No common point. Don't even talk about 3 planes. Correct? Yeah. If 2 don't intersect, forget about 3 planes. Which means 0. Good. Okay. And this junior is still surviving. I want to see who's a brain that can fry until can still survive. Okay lah, so for question 6, I just go through with you. What? What do you say? What do you say? I go back home already. Haven't I think everything is a bit weird already. Hey, are you all okay? Still behaving? Okay, ACGE is a rectangle. Show that the equation of the plane DEFG is given by this. Okay, class, how do I actually get this answer? Wait, let me go to the question. Yep. Huh? You cannot see a picture there. You cannot see the ACG. Oh, sorry, DEFG. DEFG, like that. Sorry? Yeah, OABC is also a rectangle, so I cannot have that, alright? Okay, I'm stuck. Actually, my brain also fried. How to solve this question? Take a nap first. Yeah, let me read first. Go for what? Go for lunch. Okay, I think I know how to do. Okay, settled, done already. Okay, everything come back to me. Listen up. This is a vector equation, right? Hey, cannot see. Okay, so first thing first. Since it's a vector equation of a plane, I just need to argue that 1 point, 2 vectors. Alright? I think 1 point very clearly, the point that they're using is which one? D, agree. Because D is actually 0, 0, 1. Make sense, right? No I, no J, only 1K. Make sense? The next thing is this. Okay, must imagine. DF is a vector on the plane. DF is a vector on the plane. Okay, can I find DF? How? Well, F is, okay, do you know how to find F? Oh, so what is the vector? Oh, when you have 3D diagram, you need to know how to read and get the coordinate. Which means that DF is just 632. Alright, just OF minus OD lah. 632, done, settle here. Make sense? Okay, the last one. There's the last one, the last vector. Do you know which vector I'm using? Give you a hint. I'm going to use GE. GE is also on the plane one. Okay, but yeah, so good lah. Wait, GE is actually on the plane, agree or not? You all like good married. GE on the plane, agree? Agree all? But my question, my point is I am not going to find E, I'm not going to find G. Because finding E and G is very difficult. Because the only thing that I know is OA, OC are like 3 cm, then E is how much? I don't even know. No information given to me. Correct? I only know that you draw in such a way that it's a rectangle. That's it. Correct? So, actually, I cannot find G and E, but I know G and E equals to what? Equals to CA. G vector equals to CA. Because they say that ACGE is a rectangle. Yeah, I never said that is a rectangle. I'm just finding the plane. ACGE is a rectangle. Even. Yeah, all brain fried already. We all brain fried. Cannot answer anymore. Can you now give me the equation? I didn't even pay attention. Like Elvin also like going mad. Are you okay? So do you have the equation of plane ready? Sarah is like.
Oh, yeah.
No, yes. Huh? How about what? Lambda and mu? Huh? Equation of plane eh? To form the equation of plane, I need 1 point, 2 vectors, right? What are you saying? You need 1 point, which is 0, 0, 1. I use the vector which you have to partner with lambda, 632. This vector is actually DF, correct? And then plus mu. This vector that I'm going to use is what? CA, right? Yes. Is this the answer? Yes. Okay, then please work it out. Keep your mind working. Find the equation of plane DFG in the form R dot N equal to D. Come on. Now. Do it. Yeah, there's more. We are not going home yet. You can go home more if 你讲得过你的良心，走出去了。Look deep into your heart. If whatever if your heart tell you to walk out, it's your conscience I don't know from the net got heart got conscience still up for debate. I have to observe her for a while first. Lynette, part 1, don't stare at me. Come on, do it. Guys, come on, you need your brain, continue. Technically speaking, haven't 3 hours yet, right? It's the last 3 minutes of your paper already. The last 3 minutes can do a lot of things for you. Yiling, are you doing it? Hey, I will really encourage for those who still find vectors hard. Next week, please come for the practice. Okay? Next week is, I think, Valentine's Day, right? If you have dates, bring them together to do the vectors first before you go out. Okay? Yeah. What? So patient, you can bring yours out. Nothing. Then part two is easy lah. This question is quite easy. All the behavior is kind of weird. Hey, got the answer? Okay, class, let's go. Ready? Oh, you got the answer. Oh, good. Can you see that this is one thing that you can like beginning to like don't hate math? Getting an answer is quite satisfying. Okay, guys. Okay, listen up. Do you know how to actually solve this? The plane P ax plus 2y minus 6z equals to b, a, b are constants. It's given that the 3 planes have no common point of intersection. Class. About finish already, come on. We are talking about 3 plane intersection, right? What did I say about the strategy of handling questions that involve 3 planes? Find the intersecting line between 2, right? Do you know that by looking at the alphabets, I know the intersecting line between D, E, F, G and O, B, F, B. What are the common alphabets? F and D. So do you agree that the line is FD? Yes, right? Then can you get the line FD for me? Well, you look at the picture. F is here. 6, 3, 3. D is here. 0, 0, 1. So do you agree that the intersecting line between these 2 planes is R equals to 0, 0, 1 plus C 6, 3, 2? Okay. Then, how do you actually find the value of A? If I tell you that these 3 planes have no common point of intersection, the plane P looks like this. R dot A26 equals to B. Okay, 632 dot A26 okay. 632 dot A26 is it -6? Oh, it's -6. Oh, yeah, -6. Yeah, everybody is starting complaining. I want to kill me already. Yep. -6. So it must be B. No. It is no. It's not cannot be B. It's not. It's 0. Because it hang. I think the
I think the computer also like brain fried already. Wow, jialat. Even the com is giving out. Never mind, I can use the mouse. Hey, equals to what? 0. Do you know why? Because the line at the plane is not touching. So it's parallel to the plane. Huh? Correct? No, the 3 planes have no common point intersection. Okay, the 3 planes have no common point of intersection. The 3 planes are P, D, F, G, O, B, F, D. No common point intersection. So strategy is, I look at the intersecting line between D, F, G and O, B, F, D. By looking at the alphabet, F, D is the intersecting line. So F, D intersecting line between the last 2 planes can touch P or not? Cannot. Because I already said this 3 plane cannot have common point intersection. And because it's not touching, it means that the direction vector of the line and the normal of plane P perpendicular. Okay? I really think that my sensor is not working anymore. Okay, class, how about this? You all finish part 3 and part 4, then we call it. You finish yourself, then show it to me. Yeah. No, now. Now. 5 marks, it's only 9 minutes. Come on. Yeah, do it. I will show you the hint. Do it. Sorry? I need to reset everything. I restart my computer, it's going to take longer. You can go, just ask your conscience about it. Okay, wait, let me try something. Yup, done. Okay, one last part, right? Okay. Last 2 parts. P is equidistant between the plane DFG. I think I have the equation of the plane DFG, right? Okay, what's the equation of the plane DFG? Based on the answer is r dot 1, 2 minus 6 equals to negative 6. And the point C. What is the point C? C is 0, 3, 0. Is it correct? Yeah, from the picture. Then it's given that plane P is equidistant between this and the point. So plane P should be here. Agree? Can? So if that's the case, I know that plane P is r dot A is found. Answer to A is 1. Did you actually find it just now?
Yes.
But the problem is that B is unknown. Make sense, right? Do you know my strategy? No, I'm waiting. I'm waiting for a strategy. I mean, I get someone to actually say, 七卷 not 七卷 Joanna. Strategy? I don't know. Okay, hint. I pick a point here. Okay, the point I'm going to choose 0, 0, 1. Keep it simple. Do you know what I'm going to do? What? No, I'm not going to find the distance. I'm going to cut it. This point here can be found. Because it's equidistant means that the ratio is 1:1. So that particular point P is actually equals to 0, 3, 0, 0 plus 0, 0, 1 over 2, giving you 0, 3 over 2 half. Put it inside. Giving you 3 minus 3 equal to 0. So B is 0. You see this trick before, right, just now? Okay. Then find the perpendicular distance from C to plane P. Hey, this one can, right? The last part. Find the perpendicular distance from C to plane P. Do it now, finish, you can go.
Okay, during the lecture, I didn't actually go through question 3, so I will actually go through question 3 with you all now. For these questions, for part 1, you're supposed to find the line of projection of AB onto the line L, and therefore show that M equals to 9 is the shortest distance of B to a line L is phi square root 2. So based on the information, we will know that the equation of line L is actually equals to phi 4 10 okay, plus lambda 3 0 4. Okay, so from here we can actually start and take note. We know that A is actually on the line L. So how to actually do these questions? Basically, we start off with a simple picture. Do remember that whenever you're actually doing vectors questions, start off with a simple picture. So we have A, which is given to us as 5, 4, 10. Okay, directional vector is 3, 0, 4. And this equation on the line is 5, 4, 10. Later, we will need this equation on the line to solve the other parts. So we are given that this B here actually have an unknown M. Okay, so what do? We are given the fact that this, okay, the question actually wants us to actually find the line of projection of AB onto the line L. So if that's the case, what we actually do will be, we actually form the vector AB, and then from there, we actually so-called project onto the directional vector of the line L. So to find AB, we will be having OB minus OA, which will actually give you the following. And then from there, the projections will be actually AB dot 304 hat. Okay, but take note, because this dot product can be positive, can be negative, which do not know what is it, I need to put the modular sign. Okay, and so this is the length of the projections, and we will just work it out. So the answer will be minus 30 plus 0 minus 20 over 5, giving you minus 50 over 5. Yes, it's actually a negative 10, but because the modular sign is actually 10. So we actually have the length of projection, which is actually this. Okay. This is the length of projection. We know that this length is 10. Okay, so after we get this, what does the next part ask us to do? Okay, we need to show that M is equals to 9 if the short distance from B to the line L is phi square root 2. So the information that's given to us is that this length is actually phi square root 2. So I think by looking at the picture, you know that we are actually just going to use Pythagoras theorem. So how to actually use Pythagoras theorem? We know that 10 square plus phi square root 2 whole thing square must be equals to the length of AB square. So from there we can start. So we have 10 square plus phi square root 2 square. Okay, and it will be equals to the length of the vector AB square by Pythagoras theorem. So we have 100 plus 50. So how do we actually do to actually find AB square? Is basically, if you actually follow just now, AB is actually this. So to actually get, so we just write it down. Okay, so to find this, 150 will be equals to 10 square plus m minus 4 square plus 25 square. Now I know that now you all will have the urge to actually open this up. No, because you will see that if you continue solving without opening this square up, you shift everything to the other side, it will be equal to 25. From here, m can be solved by just directly taking a square root, and you will actually get m to be -1 or 9. And we will reject m equals to -1 because in the question, we are given that m is bigger than 0. Therefore, we know that m is equal to 9. Okay, so this settle part 1. So how to do part 2? We need to find the projection vector of n, the full perpendicular from B to L1. Okay, so picture wise now, okay, this is the picture. This is actually defined as n, the full perpendicular. So how do we do it? Okay, we will actually do the standard way. So what is the standard way? First, take note that because n is on the line, we know that ON will take the expression of the equation of the line. Okay. Then what is the thing that I'm going to make use of? I'm going to make use of the fact that this is a right angle. So what do I mean? It means that BN dot with 304 must be equal to 0. So from here we can start. So how to start? BN dot with 304 equals to 0. Okay. So let's see. ON minus OB dot 304, okay, must be equal to 0. Now we already have ON to be the expression of the line. So let's do everything in one step. It is ON, this is OB. Take note, we already find out that M is actually 9. So from here, we will be able to get this expression, which will lead to so they will give you 25 lambda equals to -50, lambda equals to -2. So therefore, ON will be actually equals to, you just put it back to this expression here, okay, giving you 5 minus 6, 4, 10 minus 8, minus 1, 4, 2, which is the answer given to you at the back. Okay. Okay, so this is done with part 2. So what is part 3? Part 3 is the point X lies on the line L. Now, every time I see that the fact given to us is the point is lying on the line L, you must immediately tell yourself that the point, which is actually, when I say the point, it means the projection vector of the point, will take the expression of the line L. Okay, and then we are given the fact that O, X, C are collinear. Now, because of the fact that B and C are known, to actually solve this question, what I'm going to do is that I'm going to use, because they are collinear, right? I'm going to say that BX, okay, must be equal to KBC. Take note, I'm using BC because I know what BC look like. So again, just now, I already stated that OX will take the expression of the line, which means that BX will be equals to OX minus OB. You can do it yourself. Your expression should be 10 plus 3 lambda minus 5, 5 plus 4 lambda. Okay, and if you actually work out BC, the answer to BC will be 6 minus 30 minus 42. So therefore, since BX, C are collinear, BX will be equal to BC. This means that 10 plus 3 lambda minus 5, 5 plus 4 lambda must be equals to K, 6 minus 30 minus 42. Okay, so this will means that K must be equals to minus 1 over 6 from this rule. Oh, sorry, should be 1 over 6. Okay, K equals to 1 over 6. And because K equals to 1 over 6, we will know that 10 plus 3 lambda is equals to 1 over 6 times 6. this means that 3 lambda is equals to minus 9, lambda equals to minus 3. So once I get lambda, this means that OX will come out. You just basically sub it back to the expression of OX here. And if you do it, your answer will be minus 4, 4 minus 2, which is the answer given to you at the back. So we are done with part 3. Okay, so now we need to state the value of this area. Now, how to actually do this? The stating part is actually quite simple. Now, you can actually just draw the picture out. Okay, if you actually follow everything carefully, we have BXC here. Now, how do I know which one is actually longer? If you actually did the working just now, do you realize that you are actually saying that BX is 1/6 of BC? Because you found that K is actually 1/6. This actually means that BC is actually longer. And if you actually let BX to be 1, okay, I draw this picture here. You let BX to be 1 unit. This means that BC here is 6 units. So this 1 XC should be 5 units. Now why do I actually need this? Because this question actually is saying, okay, if you really read the question, C is a full perpendicular of F is a full perpendicular of C to the line L, this line L. Then we actually know that N is a full perpendicular of B onto the line L, full perpendicular. So what you actually need is the area. Okay, the area of this triangle, okay, the smaller one, to this triangle, the larger one. But do you realize that the length BX, the length BX over the length BC is actually 1/5? And because of this, by the fact that these two triangles are similar triangles, this will just means that this ratio between the area will be just 1/5 squared, equals to 1/25. This is something that you learned back in secondary school. So with this, the whole questions 3 will be done.